Hi, welcome to Mathematics of Chemistry. My name is Dr. English. Today we're going to be talking about mole volume conversions. Specifically, we're going to be looking at measuring by volume, converting volume to moles examples, converting mole to volume examples, doing some worked practice problems, and finally talking about gas density problems. Measuring by volume, the molar volume. The volume of a gas is usually measured at standard temperature and pressure, otherwise known as STP, which can be found on Table A of your reference tables, where we see the standard pressure either measured in kilopascals or atmospheres, and the standard temperature either measured in Kelvin or degrees Celsius. At STP, 1 mole of any gas, and I really do mean any gas, occupies a volume of 22.4 liters. 22.4 liters is known as the molar volume. Since 1 mole of any substance contains Avogadro's number of particles, 22.4 liters of any gas at STP contains 6.02 times 10 to the 23rd particles of that gas. Let's look at some examples of mole volume conversions. A mole of gas, 22.4 liters at STP, has a mass equal to its molar mass. And remember, molar mass is just gram formula mass. So the conversion factor that we're going to be using is 22.4 liters is equal to 1 mole of particles, or 1 mole of particles is equal to 22.4 liters. One of those two conversion factors. So the example is, how many liters does 3.5 moles of oxygen occupy? So our given is 3.5 moles of O2. What we want is liters of O2, and our conversion factor is 1 mole of O2 will always equal 22.4 liters of O2. So the first thing that we're going to do is write down our given. And our given is 3.50 moles of O2. We're going to put a multiplication sign and a line. If I start with moles, moles needs to go on the bottom. Moles, O2, and I know for every 1 mole of O2, that is going to equal 22.4 liters of O2 because I want volume at the end. Put in an equal sign, and then I need to make sure that my units cancel. So if I start with moles, moles needs to be on the bottom. I'm left with liters, which is what I want. So 3.50 times 22.4 liters will be 78.4 liters of O2. And that's an example of how to convert from moles to liters. Let's look at some more examples. How many liters does 0.75 moles of nitrogen occupy? So our given is 0.75 moles of N2, because we're talking about atmospheric oxygen here. Multiplication sign and a line. We want liters, which means volume. Now I know that every 1 mole of N2 is going to equal 22.4 liters. And then again, I need to make sure that my units cancel. Moles cancel moles. So my final answer is going to be 0.75 times 22.4 liters. And if I work that out to two significant figures, my answer should be 16.8 liters of N2. But again, I want to do this to two significant figures, so I need to round this to 17 liters of N2. Let's look at another example, but this time we're going to go from volume to moles. How many moles in 33.6 liters of CO2? So my given is 33.6 liters of CO2, multiplication sign and a line. If I start with liters, liters needs to go on the bottom of CO2. I want moles, and I know that every 1 mole of CO2 is equal to 22.4 liters. I'm going to make sure that my units cancel, so liters cancels liters. So then I'm going to do 33.6 times 1 divided by 22.4, which will give me an answer of 1.50 moles of CO2. And that's an example of how to start with volume and convert to moles. Let's look at one more example. How many moles in 16.8 liters of argon? So my given is 16.8 liters of argon. multiplication sign, and a line. If I start with liters, liters needs to go on the bottom, and I know I'm converting to moles, so I'm going to put 22.4 liters of argon on the bottom, converting to 1 mole of argon. I'm going to make sure that my units cancel, so liters cancels liters. And then I'm going to multiply 16.8 times 1 divided by 22.4, and my answer will be 0.750 moles of argon. So again, another example of converting from liters to moles. The final thing that I'd like to talk about today is gas density problems. Now we know that the density formula is density is equal to mass over volume. Please, please, please don't use the little triangle. Please don't use the triangle. Understand the formula. Understand your variables. Understand what you're solving for. It'll go a long way, seriously. If we know the molar mass, otherwise known as the gram formula mass, of a gas and the molar volume, which for 1 mole is assumed to be 22.4, then we can calculate its density. So let's look at an example. What is the density of 1 mole of ammonia? And we remember the formula for ammonia is NH3. So the first thing that you should always do is write the density formula. So density is equal to mass over volume. Now the mass of NH3, that's nitrogen plus 3 hydrogens, so that's going to be 17 grams per 1 mole. And the volume of 1 mole is going to be 22.4 liters. So when we work this out, we're going to do 17 divided by 22.4 liters, and our answer should be 0.76 grams per liters. And that is the density of 1 mole of ammonia. Let's look at another example. What is the density of 1 mole of carbon dioxide in 11.2 liters? So in this situation, they're giving us the volume. So the first thing that you should always do is write the density formula. Density is equal to mass over volume. The mass of carbon dioxide is 44 grams, so we're going to write 44 grams on top. They're giving us the volume, which is 11.2 liters. And if we divide 44 by 11.2, our answer should be 3.9 grams per liter. And that's another example of a gas density problem. So what did you learn? We talked about measuring by volume. We talked about converting volume to moles and did an example. We did another example converting moles to volume. We did some practice problems, and finally we talked about gas density problems. Need more help? Feel free to contact me. Have a great day.